Hello, here we have to solve a rational equation of 3 out of x minus 3 plus 5 out of x minus 4 is equal to x squared minus 20 out of x squared minus 7x plus 12. Let's begin by finding the least common denominator, and for that we need all of the denominators to be factored. So we have x minus 3, we can only factor out 1 from here, so 3 out of x minus 3 does not need to be factored, plus 5 out of x minus 4 does not need to be factored because we can only take out 1 from there, is equal to x squared minus 20 out of, we do need to factor x squared minus 7x plus 12. We begin by multiplying leading coefficient, which is 1, times last number, which is 12, and the product is 12. We list all of the factor pairs of 12. We have 1, 12, 2, 6, 3, 4. Since the product is positive, we look for sum, and we need the sum to add up to negative 7. The factor pair of 3 and 4 add up to 7. If we change the signs and have negative 3 minus 4, this will add up to negative 7, and negative 3 times negative 4 will give us a product of positive 12. You can absolutely rewrite this negative 7x as minus 3x minus 4x, keep everything else the same, x squared minus 3x minus 4x plus 12, and factor by grouping. But since the leading coefficient is 1, the factor pair will end up being your solution, meaning you will get x minus 3 times x minus 4 once you factor this by grouping. So the third denominator is x minus 3 times x minus 4. So for our least common denominator, we need x minus 3 for the first denominator, x minus 4 for the second denominator. For the third denominator, we need x minus 3, which is already included. We also need x minus 4, which is also included. So our least common denominator is x minus 3 times x minus 4. We also need to find the restricted values to make sure we don't have solutions that make denominators 0, and the best way of doing that is set least common denominator not equal to 0. So x minus 3 times x minus 4 cannot be equal to 0. To solve this, we said x minus 3 cannot be equal to 0 and x minus 4 cannot be equal to 0. Let's solve for x in each of them. So x minus 3, let's add 3 to both sides in the first equation, and we get x cannot be equal to 3. And let's add 4 in the second equation, and we get x cannot be equal to 4. So our restricted values are x cannot be equal to 3 and x cannot be equal to 4. Let's begin solving this equation by multiplying both sides by least common denominator of x minus 3 times x minus 4. Let's distribute the LCD on the left, and we have x minus 3 times x minus 4 times 3 out of x minus 3 plus x minus 3 times x minus 4 times 5 out of x minus 4, and this is equal to, on the right we have x squared minus 20 times x minus 3 times x minus 4 out of x minus 3 times x minus 4. X minus 3 divided by x minus 3 cancel out. X minus 4 divided by x minus 4 cancel out. So we are left with x squared minus 20 on the right. On the left we have x minus 3 times x minus 4 times 3 out of x minus 3. X minus 3 divided by x minus 3 cancel out, and we get x minus 4 times 3 left over, plus x minus 3 times x minus 4 times 5 out of x minus 4. X minus 4 divided by x minus 4 cancel out, and we get x minus 3 times 5 is equal to x squared minus 20. Let's simplify both sides. We have x minus 4 times 3. Let's distribute this 3 and get 3 times x as 3x minus 4 times 3 is 12, plus we have x minus 3 times 5. Let's distribute 5, and we get 5 times x is 5x, minus 3 times 5 is 15, and this is equal to x squared minus 20. Let's combine like terms. We have 3x plus 5x, this gives us 8x. Negative 12 minus 15, same sign, sum. So we have negative 12 plus 15 is 27, and this is equal to x squared minus 20. Let's begin solving this, and I'm going to bring everything to the right because x squared is positive there. And I begin by adding 27 to both sides, and we get 8x. Negative 27 plus 27 adds up to 0 is equal to x squared. Negative 20 plus 27, the difference is 7, and we have more positives, so we have plus 7. Let's minus 8x on both sides, and we get 8x minus 8x adds up to 0, so we have 0 is equal to x squared minus 8x plus 7. We need to factor x squared minus 8x plus 7. We begin by multiplying leading coefficient times the last number, which is 1 times 7, and this gives us a product of 7. We list all of the factor pairs of 7. Since it's prime, it's only 1 and 7. Since the product is positive, we look for sum, and we need the sum to be negative 8. Negative 1 minus 7 will give us sum of negative 8. Negative 1 times negative 7 will give us a product of positive 7. And since the leading coefficient is 1, we can use a shortcut and jump straight into 0 is equal to x minus 1 times x minus 7. You can absolutely rewrite negative 8x as minus 1x minus 7x. Keep everything else the same, so you would have x squared minus 1x minus 7x plus 7. Factor by grouping, and you would get the same pair of parentheses. So to finally solve this equation, we set each of these factors equal to 0. So x minus 1 equal to 0 and x minus 7 equal to 0. So we have x minus 1 equals to 0. We can solve it by adding 1 to both sides. So we get x is equal to 1. 1 is not one of the restricted values, so x equals to 1 is our solution. Then we have x minus 7 is equal to 0. To solve for x, let's add 7 to both sides, and we get x is equal to 7. 7 is not one of the restricted values as well, so x equals to 7 is our solution. That's all.